All right, welcome back, everybody. Today we're going to be talking about integrated math, practice number 13. This is called Quadratic Translations, Part 1. And just as a reminder, the word quadratic refers to equations that have x to the second power. And we're going to be doing a deep dive on quadratics all this entire 9 weeks. So feel free to come into class and be ready to talk about all things related to x squared. Starting with this. We're going to have to know how to translate between two different forms of quadratic equations. There's something known as vertex form, which looks like this. Notice that the power of 2 is here on that parentheses. And standard form, which looks like this. Has no parentheses, but we can see 3 terms in A, B, and C. And so we want to be able to take something like 2 times x minus 3 squared plus 1, which is in vertex form, and make it look like standard form. And here's how it works. The first thing we focus on is the binomial x minus 3 being raised to the power of 2. What we'd like to do is write that out 2 times. Notice that the rest of the equation is the same. There's still a 2 in front, which we refer to as the a value. There's still a number at the back, positive 1. And now we're going to drop down a line, keep the 2 there, and draw one big parentheses and leave the plus 1 at the back. What do we put inside this parentheses? We are actually going to have to multiply these 2 binomials using the FOIL method and come up with 4 terms inside this parentheses. So let's do that. X times x, x squared. X times negative 3, negative 3x. Negative 3 times x, negative 3x. Negative 3 times negative 3, positive 9. Now the a value in front, the 2, is going to have to get distributed into the parentheses. Every single term inside gets multiplied by 2. 2 times x squared is 2x squared. 2 times negative 3x is negative 6x. 2 times the other negative 3x is another negative 6x. 2 times 9 makes 18. The most common mistake I see students make in this situation is they forget that back number that's been trailing them. Don't forget that number. The 2 does not multiply that positive 1 because he's not in the parentheses, but that doesn't mean he vanishes. He just ends up dropping down at the end here. And then finally, our last step, we want to combine our like terms. We have 2 x's we can combine into one x value, and 2 numbers we can combine into one number. The x squared has no like terms, so 2x squared comes down as is. Negative 6x and negative 6x make negative 12x. Positive 18 and positive 1 make positive 19. So we took this original quadratic equation that was in vertex form, and we did the algebra and translated it into standard form. Notice how it now looks like the ABC version, right? No more parentheses. ABC situation. Taking a look at the next one, same situation, vertex form. We need to turn it into standard form. So the very first thing we do is we focus on x plus 4 to the second power, and we write it out twice. Now I'm going to drop my a value and draw a big parentheses. And inside that parentheses, I'm going to put 4 terms, the 4 terms you get whenever you multiply x plus 4 times x plus 4. X times x, x squared. X times a positive 4, positive 4x. 4 times x, another positive 4x. And 4 times 4 is 16. The negative 3 now gets distributed to each term inside the parentheses. Negative 3 times x squared, negative 3x squared. Negative 3 times 4x, negative 12x. Negative 3 times 4x again, negative 12x. Negative 3 times positive 16 is a negative 48. Don't forget to bring down the minus 10. Finally, we will combine the like terms. Negative 3x squared will just drop down because he has no like terms. Negative 12x would combine to negative 24x. And negative 48 and negative 10 would make negative 58. All right. Feel free to try that third one on your own. If you're having any struggles with it, feel free to come ask me, okay? About the bottom section, what if instead of being given the equation in vertex form, we're just given the pieces of the equation? Well, we're going to start then with the generic version of vertex form, which is a parentheses x minus h squared plus k. We need to take these pieces they've given us and plug them into the right spots in the vertex form. They've told us what the a value is, it's 3. And the 2 and the 1 from the vertex are the h and the k. So you end up with x minus 2 in the parentheses for h plus 1 for the k. Now we're going to translate just like we did before. The x minus 2 gets written out twice. We're going to multiply x minus 2 times x minus 2, which would be x squared minus 2x plus 4. We're going to distribute the 3, so we have 3x squared minus 6x plus 12, and drop down to plus 1. And finally, we are going to combine our like terms. So we end up with 3x squared minus 12x plus 13 in this situation. Let's take a look at the next one. Generic version of vertex form again, a parentheses x minus h squared plus k. The a value is -7. X minus the h value is -4. So notice how this turns out to be minus -4 in the parentheses. And then at the back plus 0. Well, anytime you have minus a negative, that actually turns it into a positive. So now we have -7 times x plus 4 squared plus 0. So notice that again, there's a minus sign that's in the original generic version. And if you ever have to plug in a negative number for h, which you will sometimes, it will be minus a negative, and minus a negative always turns into a positive. Now we're going to proceed the way we normally have. The x plus 4 has got to be written down twice. We need to multiply those two x plus 4s. We would get x squared plus 4x plus 4x plus 16. Distribute the -7. -7 times 16, if you're not aware, is -112. And then we combine our like terms. -7x squared, -28x, and -28x is -56x minus 112. Okay. Once again, feel free to try this third one on your own. If you're having any struggles with it, feel free to come ask me in class. Go ahead and tune in for part 2 if you want to see the backside homework section.